Let's take a closer look at multiplication when we're dealing with matrices. There's actually two kinds of multiplication, one that's a little easier to understand and one that's a little new if we haven't talked about matrices before. So let's start with one that's familiar to us. It's called scalar multiplication. When I talk about scalar multiplication, I think distributive property. The distributive property says if there's something outside a parenthesis, we're going to distribute it in, and if there's something in a parenthesis, we can distribute it out. So if I have my matrix A, and this is a 2 by 3 matrix, it works with any size, and I want to take some number and multiply it by my matrix, every element inside of that matrix is going to get multiplied by that C. Now, they can kind of do this scalar multiplication in some creative ways. So down here I have an example where I have A and B, and they want me to calculate 4A plus 3B. So there's two instances of scalar multiplication. So I'm going to take matrix A, and I'm going to multiply everybody in there by 4. Every one of these gets multiplied by 4, and I get this matrix down here. Now I'm going to take matrix B, and I'm going to multiply it by 3. So everybody in here is going to get multiplied by 3. Then I can do my matrix addition and add those two matrices together, get my 2 by 3 answer right here. I use some scalar multiplication on the way. The other kind of multiplication in matrices is totally different, and it's something we haven't done before. When we talk about regular multiplication, I can take two numbers and I can multiply them either way, and it works just fine. 2 times 3 and 3 times 2 are the same thing. With matrices, it doesn't work that way. The commutative property doesn't hold. So we have to have an understanding of why these work before we actually figure out how they work. So the first thing we talk about with matrix multiplication, if two matrices can be multiplied, their inner dimensions have to match. So when we're talking about inner dimensions, we're talking about the columns of the first one and the rows of the second one. They have to be the same. If they're not, we can't multiply them. So down here, I put some examples, and we're just going to check and see which one of these actually work. So we're going to look at the inner dimensions. I can definitely do this one. The inner dimensions are both 3. Down here, can't do this one. Okay, there's no way to multiply that. It's done. I can't do anything with it. Number 3 over here, yeah, I can definitely do that one because the inner dimensions are both 1. And the last one down here, I can't do that one either because the inner dimensions don't match. Now, I talked about that commutative property. Imagine what would happen on this last one if I switched them, if I multiplied them in the other order. The way it is now, I can't do it. But if I turn this around, a 1 by 3 and a 3 by 2, the other way around, I can actually multiply them. So I get very different answers when these are in a different order. So we have to look at those inner dimensions. The second half of that is the answer matrix. What I'm trying to find will have the size of the outer dimensions. So now I'm looking at the rows of the first one, the columns of the second one. That's going to be the dimensions of my answer. So let's take the two that we said we could do. This one right here, you said I could do. My answer is going to be a 2 by 1. This other one that you said I could do, because the ones matched, the answer is going to be a 5 by 3. So we have to deal with the dimensions a little bit first before we actually do the matrix multiplication. So once we've determined that the dimensions of these matrices work, now we can actually get to the business of multiplying. So you'll notice I have a 2 by 2 matrix here in A and a 2 by 2 matrix in B. So yes, I can do this, and my answer is going to be a 2 by 2. Now I color-coded this best I could, and I'm going to explain that as I go. But I'm going to take matrix A times matrix B. I know my answer is going to be a 2 by 2, so I put my blanks here, and I'm trying to fill them in one at a time. When you think about matrix A, because it's first, and because I got my rows from matrix A, you have to think of matrix A in terms of rows. So the important thing here is this is row 1, this is row 2. So I put that in red so you can kind of follow the important part of that matrix. And matrix B is second. So I got my columns for matrix B. So I have to think of matrix B in terms of columns. This is column 1, this is column 2. So I put that in red so we kind of follow that. And as I fill this in, this position of my multiplied matrix is row 1, column 1. So I'm going to take row 1 for matrix A, column 1 for matrix B, and I'm going to multiply them. So I take the first two items, first item in the row, first item in the column, and I multiplied them right here. Then I took the second term in the row, second term in the column, multiplied them, and I took those two products and I added them up. As I move over, I'm still in row 1, but now I'm in column 2. So I'm going to reuse row 1, but now I'm going to use column 2. So I multiplied the first term right here. Then I multiplied the next term right here, and I added those two products up. As I move down to row 2, now I'm going to use row 2 of this matrix, column 1. Remember, I get my rows here, my columns here. So I multiplied the first elements, then I multiplied the second elements, and I added them up. This is in row 2, column 2. So I'm going to use row 2, column 2. So I multiply the first elements right here, then I multiply the next elements right here, and I add those two things up. And that all goes into row 2, column 2. So let's look at an example. I've got one worked out here. I have a 2 by 2 matrix and a 2 by 3 matrix. So I said, yes, I can do this. And my answer is going to be a 2 by 3. So I have 3 slots in each row to fill in. When I'm working row 1, column 1, I'm using row 1, column 1. So I took the -5 times the -2, took the 0 times the 4, I added those up, I got 10. Still in row 1, but now I'm going to move over to column 2. -5 times 1, 0 times 2, and I add those two things up, I got -5. Finally, I'm still in row 1, but now I'm in column 3. So I took the -5 times the -1, the 0 times the 5, I added those up, that goes in row 1, column 3. I'm going to move down to the second row, so now I'm going to use row number 2. And sometimes circling these is enough for people. Sometimes they want to label them and say row 1, row 2, column 1, column 2, column 3, whatever helps you keep track of where you're at. So now I'm in row 2, but I'm back in column 1. So I'm going to use row 2, column 1, 3 times -2, -2 times 4, and I add those up to get -14. Row 2, column 2, 3 times 1, -2 times 2, add those up, I get -1. And finally, row 2, column 3. 3 times -1, -2 times 5, all goes in row 2, column 3. So my final answer is 2 rows, 3 columns, a lot more there than just multiplying one thing. So let's work through an example from the start. I've got a 2 by 2 matrix here, another 2 by 2 matrix here. I want to multiply those two. Yes, I can do it. And my answer will also be a 2 by 2. So I'm going to make my 2 by 2 matrix. And I need to fill in the blanks. So I'm going to work row 1, column 1. So I take 1 times 1, 4 times -2, and I'm going to add those up. And that's going to get me the -7. staying in row 1 but moving over to column 2. 1 times 3, 4 times 2, add those up. So 3 plus 8, that gives me 11. And the more you do this, the more you get comfortable, you start going a little faster. This is row 2, column 1 again. So negative 3 times 1, 5 times negative 2, add those up. And hopefully we get good enough with this or get better at this. I'm in row 2, column 2. So I get negative 9 plus 10. And I can start filling those things in. If you need to show all those steps, show all those steps. If you needed to show part way, show part way. But I end up with this matrix right here, matrix multiplication.